Hi guys, welcome back to my YouTube channel. Today I wanted to just touch on reaction rates graphs. Specifically, there are different types of graphs that you have to know in reaction rates. We can talk about the Maxwell-Boltzmann curve. We can talk about also the energy profiles, how they relate to the reactions, and then today I wanted to address the graphs of reactants or products and how to analyze them and how to conceptualize them, right? So given just a short or brief reaction scenario here, they're saying that 5 grams of zinc reacts with 100 milliliters of HCl with a concentration of 0.2 moles per decimeters cubed, and then that would be a reaction zinc the solid plus HCl which is an aqueous solution to form ZnCl2 plus H2. This is a gas and this will be in solution, right? And then let's balance it out quickly, right? This is the reaction that they're talking about. Now they say the graph below shows the volume of H2. It's the volume of what? Of H2 that is formed over time during the reaction, right? What I want to talk about is the factors that affect the rate of the reaction, right? So I want to talk about how the graph looks. What you must understand is how the graph is going to look if one of these amounts is changed, the amount of substance. Let's start with the zinc, right? So we know, for instance, that zinc is a solid, and then if I am to change the state of division or the surface area, then it means that I have affected the rate of the reaction, right? Let's say in this question they are saying that the 5 grams of zinc that is being used is zinc powder, right? Let's say they say that the 5 grams of zinc that is being used is zinc powder. Let's say the 5 grams of zinc being used is zinc pellets to begin with, right? Of zinc pellets, let's put pellets here, reacts with 100 milliliters of excess, let's say excess HCl, right? Now this shows the amount of product formed, the H2, which is a gas. What I want us to look at, what would happen if the 5 grams of zinc, so it means 5 grams of zinc is the limiting reagent, right? What would happen if the zinc powder is used, but everything else remains the same, right? So concentration, amount of HCl remains the same, right? How would that affect the rate of the reaction? So if they use 5 grams of zinc powder, then it means the reaction rate is going to increase, right? Reaction is going to be faster and completion is going to be reached earlier. So you'll see that the graph plateaus or levels off earlier than before, right? When you compare the times. Then the other thing is the rate of the reaction. It relates to the steepness of the tangent that you'd have in either one of these, right? If you compare them, you can see the green one, it has a steeper gradient. When you look, you compare it to, let's rather compare it like this, compare at the same time. So we can have, let's compare it like this. So level off here, right? I'm saying let's compare at the same time like this. So let's compare this tangent and this one, right? So you'll see the one in green is steeper compared to the tangent for the one in red for the same time, at the same time, right? What does that mean? It means the reaction in green is faster than the reaction rate, or rather the reaction rate in green is faster than the reaction rate represented in red, right? That means that this is the kind of situation that I can expect in my graphs. So for instance, you've seen the exams, they'll say this is graph A. Then either be able to draw graph B if you use powder instead of pellets, or draw graph B for the reaction, or you are given both A and B and you're meant to figure out which one will be the one with the pellets and which one will be the one with the powder, right? That should be clear now. And then let's draw another one. Let's say, what if the change that was made, right? So let's still have our standard graph here, the one that we had before, the red. And let's say now the red is representing the original conditions that we had here at the top, right? So let's say now they say they are using 8 grams of zinc pellets, right? So what has changed? The surface area has not changed. Remember, surface area of a solid is one of the things that affects the rate of reaction. Surface area has not changed because this is pellets and this is pellets, right? But the amount of the limiting reagent has increased. Before you had 5, now you have 8, right? What does that mean? It means I must produce more than I was producing before. But am I going to produce at a faster rate? No, because I have not changed the state of division, right? So watch how my graphs are going to look. You're going to have same rate of reaction. The only difference is that you are producing more of volume of the product than before. You're not producing it faster, you're just producing more, right? I hope that's clear. Then what happens in a third scenario? Let's do a third scenario where they change both the mass of the zinc and the state of division. So let's say 8 grams of zinc powder, right? So instead of pellets, they use powder, and then instead of 5 grams, they use 8 grams. What happens in that instance? Powder compared to pellets, it means the rate of the reaction is going to be faster than before, right? And completion is going to be reached much quicker than before, right? But now I've got comparing them in terms of, I had 5 grams of a limiting reagent, now I have more of the limiting reagent. So it's going to be faster reaction rate, and I'm going to produce more than I was producing before, right? So faster reaction rate and more is produced than before. I hope this video was very helpful to you, and please subscribe and share with your friends that may also find it helpful. This is basically going to assist you in understanding the graphs, the interpretation of the rate of reactions. I'm going to see you on the next video.